Hello, in this video we're going to be talking about continuous compounding interest. So what I want to do first is look at our equation A equals P times 1 plus R over N raised to the NT power. This is the equation that we use to calculate compounding interest. And you can see what the variables are there. P is your principal, R is your interest rate, N is how often we compound, and T is time in years. So if we have a bank account with $1 in it and it earns 100% interest, how much will be in the account after 1 year if we compound our interest? Let's start by compounding it annually. So let's fill in the information here. So our overall value will be, we started with $1 was our principal times 1 plus, the rate is 100%, which as a decimal turns into 1. We compound annually, so that means 1 time per year, raised to the, again, 1 time per year, 4, and we said 1 year. And so to simplify this up, 1 divided by 1 is 1, so we have 1 times 1 plus 1 to the 1, or it's 1 times 2 to the first, or rather it's just $2. So if we compounded only once, we would just have $2. We would double our money. What if we did biannually? So A is equal to, well, we still have a principal of $1 plus, or 1 plus. Our rate is still 100%, or a value of 1. This time over 2, we're compounding biannually, so that's twice per year, raised to the 2 times 1. Okay, so we're going to have 1 times 1 plus a half to the second power, or maybe we're looking at this as 1 times 1.5 squared. If we do 1.5 squared, we get 2.25, and we take that times 1, so it's going to be $2.25. So by doing it biannually, we've made ourselves a quarter, an extra quarter. If we do it quarterly, so A equals 1 times, we do 1 plus, rate is still 1. Now we're compounding 4 times, so plus 1/4, raised to the 4 times 1. So it's 1 times 1 plus 1/4 is 1.25. 4 times 1 is 4. So notice we are, in our annual value, we're only multiplying by 2, but we're multiplying by 2 but 1 time. In the biannual, we're multiplying by 1.5, which is a smaller number, but we're doing it twice. And in the final one, we're multiplying by 1.25, but we're doing it 4 times. And here, our value becomes, if we run this through a calculator, 2.44, or $2.44, which is even more money. Now, we know that the more often we compound, the more money we are going to get in interest. So what happens if we start compounding 8 times a year, 12 times a year, 52 times a year, and so on? Well, instead of having to figure all this out, I created a chart here for you to say what is the case, how much money will we have after so many times compounding. So you see what we got for a yearly and biannually and quarterly, and that's already listed there for us in these 3 spots. So we compounded once, twice, and 4 times. If we did it monthly, if we compounded 12 times, we'd have $2.61. If we did it weekly, we'd have $2.69. If we did daily, we'd have $2.71. If we did it if we did it every or twice daily, we're looking at $2.72, which is probably going to be our best value. We're not going to be able to round up much more than that. But I went out even further. I went out to every half second, which means we would compound 63,072,000 times per year. And we make $2.71828119 essentially on this investment. And so what happens as we make n bigger and bigger and bigger, what happens is the money in our account approaches a new constant that we're going to talk about, the number e. E is the number 2.718281828. Much like pi, e is an irrational number. It goes on forever and ever and ever, never stops or repeats. Now, e is a constant that we're going to use to calculate continuous compounding interest. And so, if I continue to use the same example from before, I have a new formula here, and it's sometimes referred to as the PERT formula because it's our principal p times e raised to the r times t. Our principal was still $1. We're going to take that times e raised to our rate was 1, and the amount of time we had that in there was 1. And so really it's 1 times e to the first, or it's just the same as e, or it's our 2.71828, and so on, or rather $2.72. So if we compound continuously, that's going to get us our best value of $2.72. And so that's the introduction to continuous compounding interest, the best possible rate you can get in any sort of account. For now, we are done.